EasyVPN is an old technology, old VPN. Now to understand this EasyVPN, we got two clients, remote EasyVPN clients, and we got EasyVPN server. Now what is this EasyVPN? Why we go for EasyVPN? The simple reason is it's easy. How easy it is? It is so easy, like you need not to configure much on the client side. On the client side, all that you need to know is the group ID and the key to talk to the server. There is no phase 1 configuration needed, there is no phase 2 configuration needed. This is the easiest VPN. The VPN that we are going to learn next is GetVPN. In GetVPN, at least phase 1 configuration you need to do on client. Phase 2 is downloaded from the server, where in GetVPN. Whereas in EasyVPN, you don't even configure phase 1 here. All that you configure on the client is just the key and the group ID. That key and the group ID, we predefined it on the server. And the server, when it finds the correct group ID, exact group ID, and the key from the client, server opens its pool and give one address from the pool for the client to use whenever client talks to the server. And they also undergo phase 1 and phase 2 negotiation. So those things will be downloaded to R2 and R3 dynamically using that virtual interface to which the IP address from the pool has been assigned on R2 and R3. And then from then onwards, whenever a packet goes from R2 to R1, always the packet will be sent encrypted. EasyVPN is easy. You don't have much configuration on the client. On the server, we have some 7 steps of configuration. These are the 7 steps. First, you enable AAA. Once AAA is enabled, create a pool for the client. From this pool only, an IP address will be given to the client who successfully provides the group ID and the key. And then we configure the ISA-KMP phase 1. And then we configure ISA-KMP phase 2. In between 2 and 3, there will be another phase. I want to make this as 4, 5, 6, 7, 8. Actually, there is another one here in the middle called step 3. In step 3, what happens is we create client configuration group ISA-KMP client configuration. We can say it as local database, ISA-KMP local database. So based on this client configuration, the clients will be registered. So in the client configuration, what we define is we define the group name, we define the key. This group name and this key, what we have given on the server, we will also configure on the client, and the client will use the exact group name and the exact key to talk to the server, and server acknowledges the client based on this. So that will be step 3. Step 4, ISA-KMP. Step 5, IPsec transform set. Step 6 is something called dynamic map. What is dynamic map? Because you don't have a fixed client, because the clients are to be learned dynamically, the transform sets are not defined on the client. The registration of client happens dynamically based on this phase 1 group ID and the key, and the transform set will be downloaded to the client, whoever dynamically registered with this server by using the reverse path, reverse route. So that's what we call it as dynamic map. And then crypto map, which will put everything together, like we map AAA that you configured for authorization of network, and then we say also respond to the client if the client configuration matches with this group ID and the key. And we also say the normal crypto map IPsec ISAKMP along with the dynamic map name, whatever the name that you define, we will be defining it under the crypto map. So what does the crypto map do? The crypto map does three things. One, it puts the AAA and the dynamic map and the address response together. So once this crypto map puts all these three together, we can apply that to the physical interface. Without crypto map, I cannot assign those things directly to the interface. That's why we go through the crypto map. So if you are confused, no need to worry. When I'm going to configure it, you will be more clear. So this is this is the server side configuration of Ezvpn. Server side configuration. So what happens when a client approaches the interface? Interface will check the crypto map. What does crypto map has? Crypto map has got the AAA information for authentication. I need to use local database. How do I know that I need to use local database? Because I have configured AAA. And AAA says use local database. What does local database have? Local database has got this group ID and the key. And whatever the group ID and the key matches, I'll respond with an IP address. And not only that, I will use the dynamic map to register them. So these are the three functions that is binded to the physical interface. So when a client talks to the interface, these three will be kickstarted, and on successful association of these three, VPN will be formed. Right, now let's go back to our topology. Now we need to reach actually each other. R1 and R2 and R3 should reach each other. So what I'll do is, I'm on R1, and R1, this is the IP address that I have configured, show IP interface brief. I have the IP address on place, and also I would like to run OSPF show IP OSPF interface brief. I got OSPF running only on fast Ethernet. If I want, I can also run it on loopback. Okay, so OSPF is running on this router. So OSPF is running on this two interface, and internet is also configured already. Internet is ready to serve. If you see the internet, this is the internet router which is emulating as an internet. Show IP interface brief. Show IP interface brief. These are the two interfaces, and it is up and running. Show IP OSPF interface brief. I got OSPF running on this two interface, and then when I type show IP OSPF neighbor, I got router 1 as the neighbor. Now what is not configured is router 2 and router 3 is not configured. So router 2 and 3 are fresh. I would like to configure router 2 and 3. Router 2, let's configure quickly. Enable config T hostname router 2. Interface loopback 0, IP address is 10.2.2.2, 255.255.255.255, IP OSPF 1, area 0, interface fast Ethernet 00. Let me show you the interface name. These are the interface name. So fast Ethernet 0 on R2, fast Ethernet 0. IP address is 192.1.23.255.255.255.0. No shut. IP OSPF 1 area 0. Alright, now I'm expecting an OSPF neighbor with router internet. Let's see. Yeah, we got the neighbor. Show IP OSPF neighbor. I see that router internet IP address has got neighborship with this router. Now let us do router 3 configuration. Similar to router 2 before that, let me save this. Saved router 3. Enable config T interface loopback 0. IP address is 10.3.3.3 255.255.255.255, and then IP OSPF 1 area 0. Interface fast Ethernet 0. IP address is 192.1.23.3 255.255.255.0. IP OSPF 1 area 0. No shit. Now I'm expecting another neighbor. Host name is R3. Alright. So look at this, we got the neighbor. Now I can ping from here 10.1.1.1 with my loopback address 10.3.3.3. I can ping, but this is not a secure communication. To provide security only we need Ezvpn. Look at this, I don't have IPsec. Show crypto ISA KMP security association, nothing. Show crypto ISA KMP IPsec security association, nothing. It's not configured, no VPN is up. And then there is also one more special command for Ezvpn. Show crypto IPsec client Ezvpn. This is also nothing, null. We have not configured anything. So let's do it from the server. Server configuration, we have discussed that we have 8 steps. So let us start with step number 1. Step number 1, enable AAA. AAA, new model. That's the command to enable AAA. Plus, why do you enable this? To authorize to authorize R3 and R2 to form Ezvpn. Now that is talking about something related to network. So the command goes like this: AAA authorization, network authorization, and give any name. I'll give auth, and then I'll say use a local database. Okay, and this is step number 1. Step number 1 is over. Step number 2 is...
What do they mean by use the local database?
See, when I say local, what happens is it'll go and check the local database. Means, it won't go and check ACS, it won't check the Radius server, or it won't check the TechAct server for authentication. It will check the router itself. In the router, you have the key and the group configured. You're going to configure this group and the key. So it will go and it won't check outside, it will check inside the router itself.
Inside the router 1.
Yeah, inside the router 1 itself. It won't search for external route source. Okay, next, this is phase 1. Phase 1 is over. Sorry, step 1 is over. Step 2 is creating a pool. Create IP local pool. Create IP local pool. Give a name. I'll give Ezvpn. So easy pool, and give any address. It can be any address. So I can give like this 192. Or why 192? Let's give something interesting here. 20.20.20.1. From this is the starting address. 20.20.20.20. That's the end address. So I'm giving this address in the pool, and this address will be given to R2 router. But for this, we don't have any interface with 20. But this will work. This will be given to a logical interface, and routes will be established using the reverse route concept. Reverse route we will be configuring on dynamic crypto dynamic map. So when we go there, I'll explain you. So we have created a pool. Step 2 is over. What is step 3? Step 3 is creating an ISA-KMP local database. You ask me what is local. I'm showing you now what is local. This is what local. Crypto ISA-KMP client, configuration group. For this I'm going to give a local database name. I'll say easy client. And now here I need to define key here. Key is, I'll say CCI security. So this is the group name, and this is the local group name, and this is the key. These two should be given by the client if client wants to form an Ezvpn. These two are very important. Apart from this, you can also give a DNS address, but they are all optional. DNS address, Win server address, domain name, those are all optional. And now I need to bind the pool that I created, the pool name that is Ezvpn. Three main things in the local database. One is the group name, second one is the key, third one is the pool name. These three we need to configure as a local database. Alright. Now it is
so
this
that pool, hello?
Yes.
That pool is the where does it come?
I have created the pool, this one. I'm calling this. I'm calling this here. Why I'm calling this here? Whenever a client comes with this group name and this key, I'm going to use this pool to the client.
Okay.
You can have many pools and many clients with many group policies.
Yeah,
For this group, I want to use this pool. All right.
Sure.
So this is step number 3. What is step number 4? Step number 4 is this one. ISA-KMP phase 1. So you know how to create ISA-KMP phase 1. Crypto ISA-KMP policy. And for encryption, I want to use 3 days. And for authentication, I want to use pre-shared. And for hashing, I want to use MD5 or SHA. And for Diffie-Hellman group, minimum recommendation is group 2. Alright, and then the transform set, crypto IPsec transform set. I'll give a name tset. I want to use the combination of ESP 3 days and ESP MD5 and HMAC. This is our step number. Transform set is step number 5 is over. Step number 6 is crypto map, dynamic crypto map. Now this is the command crypto dynamic map, and give a name. I'll give tmap. This name you should remember because we will be binding this on the crypto map. The next step we'll be calling this name. Now inside this I need to define the transform set that we created. The phase 2 transform set name is tset, and then I need to say reverse route. Yes.
Why did we need a dynamic map?
Why we need dynamic map, I already explained to you, because the clients do not have any phase 1 phase 2 configuration. They cannot do phase 1 phase 2 negotiation. So only based on the group ID and the key that they provide, I need to dynamically register them and push them all those phase 2 and phase 1 parameters to R2 and R3 and form a VPN.
Okay.
So there is a need for dynamic learning, and R1 will be providing an IP address to R2 from the pool. We created a pool starting with 20.20.20.1 address. So with that, the packet will be reaching So based on the reverse route, R1 can reach back to R2 and R2 can reach R1. So that's why we say reverse route. Next is the final
Bro,
step. Yeah.
Prof, do you know one thing? Prof, hello?
Yes. This dynamic map is not going to pull R1, R2 or R3 for registration. R2 comes in search of R1. In R2 we will tell who server is. We'll give the IP address of R1 on R2. So R2 will send a request with the key and with the group ID, and that will hit this port, and this port has got the crypto map in it. It will authenticate using the local database using AAA, and then it will authorize R2 to be a part of R1's Ezvpn. Only then this will kickstart. Dynamic map will register R2 and send the before register. Yeah, it will register and then it will send the pool an address from the pool, plus it will also set the transform set. Same thing, whatever you set in the left in the server, it will be seen on the router. It will be seen on router 2's virtual interface. And reverse route will be used to go back from R1 to R2. That's what the use of dynamic map. It's not going to pull or push. Yeah.
Okay.
So the next step, if you see the next step, you will understand everything. So the next step is crypto map. You give a map. I'll say C map. Crypto map C map. ISA KMP authorization. Authorization list name is auth. And now, auth. Next is crypto map C map. Client configuration should be, look at this. For the client configuration, how the client is going to be configured? Based on the response. This R1 is going to respond to R2 by saying this is what my phase 1 and phase 2, and this is what you need IP address. Take it. It will give from the pool. So how it knows the transform set phase 2? This command, crypto map C map. Give any name, IPsec, ISA KMP, dynamic map. What is the map I gave? D map, I think. Is that right?
Yeah, D map.
Dynamic map name was D map. So we are putting all these three together, and we will assign these map C map to the interface. So on the interface only everything is getting initiated. Crypto map C map. That's all. You will see ISA KMP coming up now. It has come up. So what happens when R2 comes? When R2 comes to R1 on this interface, it will meet the C map. What C map will say? It will say, hey, come on, first let us authenticate this R2. How to authenticate? It will go and check AU auth. What auth says? Check the local database. What does local database says? It says the group ID is EZC, and then the password is CCISEC. If that matches, what it needs to do? The second step, it needs to respond. How it responds? It responds by giving an IP address and pushing phase 1, and phase 1 key exchange happens. Then it does phase 2 using this DMAP. In DMAP, what we have defined is the transform set, which is phase 2. And when all these three happens, you are done with the VPN. Your VPN will be established. So on the server, this is the command. Let's go on the client. Client configurations are very simple. Client configurations are very simple and straightforward. The command is this. We need to create crypto IPsec client, EasyVPN client, and then give any name. I'll give name as EZ. This name I will be using under the interfaces, and this name need not to match with your group ID. This is not going to match with your server group ID. It can be anything. But what should match is this group name, EZC. This is the name that we gave on the server, and the key is CCIE-SEC. These two must match with this with the server. And then who is the server? See, I'm saying peer. Server is 192.1.10.1. So I'd like to show you on the notepad the client configuration. The configuration goes like this: crypto IPsec client Ezvpn. These are all commands, and here the name can be anything. This can be anything. I'm just typing easy, and then you need to say group. This group should be the group ID that I'm going to type must match with the group ID that I gave on the server, which is EZC. And then the key that I gave there on the server is CCIE-SEC. And I need to provide the IP address of the peer, which is my server, that is 192.1.10.1, and the connection type automatically it should connect, and then this router mode is client mode. That's all. Now I need to get inside the loopback interface. Loopback interface is going to be the inside interface, and then this fast Ethernet is going to be the Ezvpn outside interface. So what I need to do is, first I need to go to the loopback interface and say,
sorry, you know that I forgot what you told me about Connect Auto.
see, Connect Auto means, as soon as I put in this command which I am typing now on the interface, as soon as I put in, it will start negotiating. There is also manual command where we manually start the VPN. Auto means even we don't start, it will start automatically.
Okay.
So on the interface, loopback interface, we say crypto IPsec client Ezvpn, and then the name I gave is EZ. So type that EZ here. Inside, first configure the inside interface, and then you can go to the outside interface. Outside interface is this. Copy the same thing and paste it here. If you don't say inside or outside, it means outside, but it is nothing wrong in giving outside command. That's all we need. Now I'm going to copy this and paste it to both the clients, R2 and R3. So R2, I'm pasting it. Something wrong. It is config T. F I missed. Select all, copy. Okay. I'll do it on R3. R2 is busy. Alright, R2 is ready. Now I'm going to see that R2 will look at this. ISAKMP is come up, and accuracy mode failure. The peer at 192, it is okay. Give some time. You will also see the IP address. Show IP interface brief. You see there is no okay, wonderful. So you don't have a new interface, but once it receives an IP address, you will see a new interface coming. You need to give some time for that. Meanwhile, I'll go to router 2 and paste the same. Alright, router 2 I have pasted. Something is wrong. Let me find show IP OSPF neighbor. I do have a neighbor. Let me try pinging 192.1.10.1. This ping is also happening. Then I must show IP interface brief. Something it is saying. IKE packet from 192.1.10 was not encrypted, and it should have been. Okay. Let me go to router 1. Yes.
£5.
Sorry? What did he say? So, this router has got hanged, and whatever we have configured is correct on both the side. By this time, if this GNS is proper, we should have got an IP address and packet would have got encrypted. There is nothing missing. Every command is there on place. Yes. Stop.